taking forward from the last class, in the last class, we have tried with um, multilinear regression, but our accuracy score was very bad. So we thought of using the another one. So here, let's do it with the another data set, guys. And let me go to our coding environment. Here, this one. And we will go with artificial intelligence, and we will go with 24. Okay. Now here, starting the collab, and I'm getting a new data set, guys, over here. So if you check it out, the Google, in the Google, there is calories data set from Kaggle. So you can use this. Calories burned data set. Now I will run it over here. Okay. Now this is the one which is input data. You are having two data sets over here, and says two parts over here. Like this is already been downloaded, guys. That is this. You can see two parts. Okay, you can download it. Then you will be having two parts over here. These two parts I'm uploading in our drive over here. I'm going to put on. Okay. Now these are the two of them. Now, if you look at both, I will show you one after the other. So this one, it shows the details of the person. This one shows the how many calories he or she burned. Okay. So now first we are going to, I will just put it as multilinear regression. Now here, first I will do import pandas as PD, import numpy as NP, import matplotlib.pyplot as PLP, and import cborn as SNS. Okay. Now here, I'm going to use it. I am mounting my drive. see that. Okay. Now, just a minute. Okay, I have it over here. I'm just mounting it because I've done something wrong over it. Right? My drive, EMA, and here I will have um, AI and here. So first I'm getting the address of the exercise. So I will use it as pd dot read underscore csv df. Okay. I think I have done mistake. PD is not. Okay. Yes. That's okay. Now let's see what is this df is. DF is having the gender, age, height, weight, duration. Duration is number of minutes he's been working, and heart rate and body temperature. Clear? This is what it is. Now, uh, now, yeah. Now, what I'm going to do it is I'm going to get it the other one calories. DF1, I will take it. Sorry. PD dot read underscore CSV, PD dot read underscore CSV. Here I will give it as okay. Now, here this is having the gender, age, height, weight, duration, heart rate, and body temperature. Now, in this, we are having the calories. Now, what is the connection between this one and this one is this user ID. You can look at this user ID over here. Okay, now you can use the user ID. The same based on the user ID. These are the details of the person, and this is the number of calories he burned. Now, till here, it's okay. Okay. Now, yeah, till here it's okay. Now we are going to combine these two. See on what basis you are going to combine this. We can use the concat, but there is a common column with the common elements values. So I can go with the merge. So PD dot merge, I can use it over here. DF comma, so DF comma DF1. Okay, now let's see this. See, it is merged based on. See, you got the last calories. This I will store it in the DF. Okay, now this is looks perfect for us. Now, what I'm going to do it over here is we are going to find out the feature selection. First, I'm going to look at the feature selection. What do you mean by feature selection? That is nothing but you are going to select whichever the features are important for us. So feature selection. Okay. If you look at this, I don't want the user ID. Okay. I will remove the, even gender is not required because based on the gender, I don't think so that weight will be reduced or number of calories are burned. Now, for example, if two are there, one is male, one is female, both a weight is 60 degrees. Okay, 60 kilos is a weight. Now, both of them are working on their treadmill or workouts. They are doing it for next 30 minutes. Okay. Now, like they did the workouts on different ways. Now, it doesn't mean to say that if both are same weight, if the male is there, there will be less will be reduced and female will be there, more will be reduced. It's nothing like that. So what I'm doing is I'm pulling off these two. Or if you want to go with the gender also, we can go with the gender, no problem. I will drop off this one. Okay. df.drop. I'm going to drop user ID. ID over here. Access is equals to 1. It's dropped. Now this one we will make it as a permanent change. Like I will give it as in place is equals to. Okay. Now df I got it. This one. Now yeah. Now what I'm going to do it is I will find the NANs. Okay. Now here df dot head is this. We are going to give it df dot is NA dot sum. There are no NANs. That's fine. Now let's see the error detection. Okay. Okay. Now what I'll do it is I'm going to go with first let's see the gender. Gender, I can't apply the box plot. I will see the gender. Gender will be male or female. So first I will see the gender. df square brackets. I will see the gender. Now let's see them all male and female. I will see the unique values. That is there anything else is there apart from your male or female? Male, female. Okay. Now then afterwards, df um, I will give it as gender dot value counts. Value counts will give us how many values are present inside this. Female is 7,500 and male is 7,400. Almost they are same. So we are fine with this. Now let's take it the numerical columns. Numerical columns again, we will not we will check it out all the numerical columns. What are their errors? So we will do it with SNS dot box plot. I'll give it as DF. Now let me run it. Yeah, age is not having errors. Height is there, weight is there, duration is there, heart rate, body temperature, and calories. Now I can't see them. I will add PLT dot. I will copy this. I will give it as xtext. PLT dot x x. And we will have over here rotation is equals to 90 degrees. Now you can see them. I will remove them. Here they don't show. Here. Okay. Now here I will see. What I'll do it is height, weight, like duration, heart rate, and body temperature. These things I will consider because this is a dependent column. We will ignore it as of now. Okay, we will consider these of them and we are going to do it. So first I will get the column names. Df dot columns are these. Now I will take these columns. Okay, here I will give it as calls. Now I'm not going to consider the dependent column, so I will remove the this one calories and gender. Now, as I told you, like whenever we are removing the errors, try to avoid the dependent column first thing. So again, if you are doing after doing everything, your score is very bad because of that dependent column. Then when you come down to the dependent column, delete the errors. Don't rectify the errors. Okay. But if the errors are more than 50% or 30% or 40%, then you try to rectify. That is the last option. Okay. Otherwise, your whole calculation will be gone over there. That's why you should avoid touching the errors in the dependent column. So for C in calls, okay, I will print C. Okay. Now here we are getting each and every column. Now I want to put this column in our data frame and I want to get the values data. So for C in calls, here print, I will give it as df of C. Now here I will give it as time dot sleep of 1 second, but here I will use it the import time. Now you see individually you will get the values. We are getting the values. That's good enough. Now I'm automating the error detection process, guys, completely. So I'm taking the same over here, or let me write it down again. Here for C in calls. Okay. I will print C. Okay. Now here instead of df C, I will take it and dot skewness dot round, and I will store this one in a variable sk, and I will print sk. And I will use the time lapse to see that whether this is working. First one is normal distribution. Second one is normal distribution. Third one is also normal. Fourth one is normal. Fifth one is normal. And sixth one is a skewed distribution. So almost all of them are normal distribution. Only sixth one is skewed distribution. Okay, now that's fine. Now, so what we are going to do it over here is, one second. If it is normal distribution, we will go with the mean standard deviation. If it is skewed distribution, we will go with IQR. Now I'm going to put it in a single stuff. I'm automating the things. So what we are going to do it is, for this is the same. I'm going to copy it. And here I will give it as if sk is equals to 0.0 or sk is equals to minus 0.0. Okay, then I will print it, but not I will print it, because if it is 0.0 or minus 0.0, we are going to consider it as normal distribution. So I will calculate the mean first. df of c dot mean. Okay, next one, s is equals to df f is equals to df of c dot st. Okay, now here we are going to go with lower limit is equals to m minus 3 into s, and upper limit 3 into s. Upper limit is equals to m plus 3 into s. Okay, here is the one. Lower limit m minus 3 into s, upper limit m plus 3 into s. Now here I will apply the capping mechanism. So df of c, we are going to take the each and every value, a map, and I will put it in the lambda x colon. I'm going to give it as if x less than lower limit, then I will put it in the lower limit. I will replace it with the lower limit. And else, if x is greater than upper limit, I will replace it with upper limit. Okay, else x. Okay, let's check it out once again. I calculated the mean. I calculated the standard deviation. Lower limit is m minus 3 into s. Upper limit is m plus 3 into s. And df of c map is equals to lambda x. If x is less than lower, we'll replace it with lower limit. X is greater than upper, replace it with upper limit x over here. Okay, that's fine. Till there, it's okay. Now I want to save this one in our same column is equals to this. Now this is if it is normally distributed. What if else colon I will give it as if it is a skewed distribution. Else means skewed distribution. Skewed distribution means we will go with IQR. In order to calculate IQR, we should know the Q1 and Q3. Let's calculate the Q1 first. Q1 is equals to PF of C dot quantile, quantile of 0.25. Okay. Now Q3 is equals to PF of C dot quantile 0.75. Okay. Now I will give it as over here. Now we got the Q1, Q3. What is IQR? IQR is equals to Q3 minus Q1. Okay, Q3 minus Q1. Now we know the Q1, we know the Q3, we got the IQR. Let's get the lower limit. I will give it as lower because lower limit is used earlier. So I will use the lower. That is Q1 minus 1.5 into IQR. Into IQR. Now next one is upper is equals to Q3 plus 1.5 into IQ. Okay. Now I will give it as, I will go with the same PF of C dot map lambda X or A or B, anything you can go with. It's not. I usually go with X. I'm going. You want to go with Z, you can go with Z. If Z less than lower, I will replace it with lower. Else, if Z greater than upper, then replace it with upper. Else, keep it Z like this. Okay. Now we are going to save this one in the CMTF. Now let's have a quick look over here. See, we are applying the IQR mechanism because it is a skewed distribution. How we are coming to a conclusion that it is a skewed distribution? The skewness is not equal to 0. If it is equal to 0, we will consider as normal distribution. This is normal distribution. I'm just putting a comment over here. Normal distribution. Obviously, when it is 0, it is normal distribution. Then in that category, we will say it as a skewed distribution. Skewed distribution. And here Q1, Q3. Q1 is the first quartile, which is 25%.